This is a demonstration of the wind uplift resistance of the MR-24 roof. This particular test is similar to the test conducted at Underwriters Laboratory. They certify the wind uplift resistance for roofing. We also test to a variety of other standards such as the Corps of Engineers, and in Dade County, Florida, for example, where they actually not only do wind uplift testing, but they do projectile penetration testing as well. With this test though, we're looking at a 10-foot square piece of roof just like it would be in your building. We've left off the insulation off the bottom so you can see underneath here any liner or so on, just see what's going on. Here you have the typical purlin spacing, roughly 5 feet on centers or whatever spacing you want to test to. The attachment clips back here attach the roof to the purlin system. This is a typical clip and a large diameter screw bolt fastener for that attachment point. And what we're going to do is evacuate the air on the top side, let atmospheric pressure push up on the bottom side, and create an uplift force which is measured in the manometer here on the ground. There's really 3 levels of performance of this test. There's a UL Class 30, a Class 60, and a Class 90. The MR-24 roof is available as a Class 90 in its standard configuration. You don't have to do anything special. You just install it according to the drawings and you have a Class 90 UL rated roof system. So we're going to step through this. Now Class 30, the uplift, you begin to see the deformation of the panel. The uplift pressure is about 45 pounds per square foot. Now that's the same pressure that's achieved in a 120 mile an hour wind. You say, well gosh, that's pretty high. Why would you bother to go all the way to a Class 90? Well, what happens is that 45 pounds per square foot is the pressure of just the horizontal wind. The wind blowing into the side of the building, but it's got to go someplace, so it rushes up the building. Well, there's more wind at the top, and so it creates a little, almost like a mini tornado, high forces around that perimeter of the building. So this 45 pounds per square foot of pressure can be achieved at a lower wind speed simply due to the aerodynamics of the wind blowing across the building. The next level of performance is a UL Class 60, which is 75 pounds per square foot of uplift pressure. And during this phase, we'll also run a cyclic phase. Since wind is not a nice static load, you have to cycle it back and forth to simulate gusting. And so at this point, we actually simulate that by changing the pressure. And if you've passed this level of performance, then you continue to test to the next level, which is a UL Class 90. Now that's 105 pounds per square foot, which is equivalent to a 200 mile an hour wind pressure. And again, at this point you can see the deformation. One of the things I always like to point out, the seam that we make with this panel won't come apart. Now it might kink in the middle or one of the supports when it breaks, but you still have a weather-tight membrane inside the building. The other thing is we're actually pulling a vacuum on this seam. Nobody else could do this. Their seams are so loose that the air would flow through. We have to put a plastic sheet under it to test it. In this case, it's not only watertight, it's also airtight. And so long as that deformation is not permanent, it returns back to its original configuration. You've not exceeded the elastic limit of the steel, and you can do it time and time again.
It's all part of the Butler difference.